So we're doing some more electronics this time. We're going to be wiring up our Victron Orion DC charger, and once we've done that, we'll be able to charge up our batteries just from driving down the road. It should be pretty good. So as you can see, we've already done most of the 12-volt electrics, so we did that in a previous video. And if we look at the wiring diagram that we had from that, we've got our 3 solar panels on the roof, and that is feeding power in through the charge controller, through the links distributor, which is basically just some bus bars and fuses, and then into the batteries to charge them up. And then over here we've got our 12-volt fuse hub, and that is this one, and that is powering things like the fridge, the lights, max fan, heater, basically everything that's running off 12 volts, and that's already hooked up and working, good to go. But what we didn't do was these 2 bits over here. So we haven't done the 230 volt AC side through the inverter, so we're not doing that yet, we're going to leave that. And we haven't done the DC charger side, so this is what we're focusing on now. So this DC charger box here is just this. So it's the Victron Orion and the 12-12-30 model we've gone for. What that means is these numbers are the voltage and the amperage, the current. So the 12 is the voltage of our starter batteries, the van battery, and that's going to be charging up our batteries, which are also at 12 volts, using a maximum current of 30 amps. And you can also get 24 and 48 volt ones, but this should be perfect for us. So this is the alternator, and that's a little device which sits inside the engine bay, right next to the engine. And then what happens is, as the engine is turning round, it uses a lot of mechanical energy to turn this wheel, and attached to that is a pulley, and then the other end of that is attached to the alternator. So basically, as the engine is going round and round and round, this wheel is going round really fast, and that is driving some electromagnets round and round and round in here, and that then in turn generates some AC electricity, which then goes through a small device called a rectifier to convert that into DC electricity, which is the kind we want in the van, and then just pass it through a voltage regulator just to make sure it's all nice and stable to be used. So basically it's just turning the mechanical energy from the engine into direct current electricity that we need for everything in the van. So that is recharge the starter battery, and also to power everything the van uses. So what we're going to do is basically, as the alternator is charging the starter batteries, the DC charger will then attach to the starter battery, and then effectively, as the alternator is going around charging the starter battery, it will also then in turn be charging our batteries. So we're kind of piggybacking off it basically.
Pretty cool.
Yeah, it's pretty cool. So if we look inside the bonnet, then there is an alternator right there. So yeah, compare it to Abby's diagram. I think that's pretty good.
Not too bad.
And you can see the pulley that's attached to the engine there. So yeah, that's basically spinning around and generating the electricity, which is then going back through that cable there. And then obviously alternators come in different sizes. So we know we've got 150 amp alternator on there. And then our batteries for the actual van are under the driver's seat. Get out of the way. Then our van batteries are actually here, and we have the dual transit model, so we've got 2 starter batteries under there connected in parallel. And we thought it'd be cool to know how much amps the van actually takes with everything on basically, so we know how much buffer space we've got and how taxing it's going to be. So to do that, what we did was we got one of these, a fairly cheap amp clamp meter on Amazon, and what we can do with this is we can basically clamp it around a wire and it'll tell us what the current is through that wire. So we thought we'd do a little test and yeah, just turn on as much as we can in the van and see how high we can get it to go. So firstly, we actually have to undo the little bolts here on the van battery cover. Help if we had a screwdriver or something, wouldn't it? Well, not even a screwdriver, what is it? Bolt thingy. So all I have to do is just clamp this around one of the wires going to the battery. So that is the positive, and you can see it's drawing basically nothing at the moment. Abby, do you want to turn the key a couple of clicks? So that's about 13 amps. The camera's come on. So that's our reversing camera turning on there, and we're about 10 amps. So headlights on, it's up to 14 amps. What else have we got?
Fog light.
Fog lights. full beam, 20 amps. Windscreen wipers, maybe the hazard lights. That one's quite funny. You can see the current changing as the indicators go on and off, and the windows. So it just peaks above 30 amps, and I think that's pretty much it. Got everything going. So the other thing we can do, or try, which would be quite cool, is to see how much current it actually uses to start the engine. So what have we got? 220 amps, 221. Pretty cool test, right?
Yeah.
That was quite fun actually doing that. So our alternator is 150 amps, and with everything in the van on, it's using about 30. We've got quite a lot of headway. They say you should have probably about 20% buffer of what's left. So 30 amps for the DC charger should be absolutely fine on our alternator, which is good.
Cool. So we have already run the wiring for our DC charger, and we did that in our pre-wiring video. And we've gone for 16mm squared wires, which run behind our cladding here, behind the shower, all the way to the front, through the bulkhead, and then back again. And we think that the total distance of that is about 7 to 10 meters or something like that. And the way that we chose those wires sizes was by using this chart. And you want to avoid voltage drop because we've got quite a big distance, and this takes that into account. So with the kind of distance that we've got and the kind of amps that we'll be drawing, it gives you a 6-gauge wire, which if you look over here translates to a 16mm squared cable, which is also the maximum that the DC charger can take anyway. So
Cool.
Should be fine.
Right. Now hopefully it should be quite easy to wire it up, right?
I hope so.
I mean, literally all the cables already there, so we just got to join each end, and that's it.
Yeah.
Should be one of the easiest projects.
But the first thing we've got to do is pin the cables onto our garage wall.
Alright, so we've got them all pinned up. It's looking a lot neater now.
Yeah, it's really nice to get those out of the way finally.
We've got little arrows that look like kind of charging arrows going all the way to the battery. It's quite fun. Mario Kart boosters. Should point out that there looks like there's loads of wires, but actually they're not all for the DC charger.
Oh yeah, these ones are for our diesel heater, and this little one is for the data cable for the what is it? The starter battery.
That one's just showing how much voltage in the starter battery.
Yeah.
Cool. Alright, now we've just got to actually get the ends on these wires so we can put them in.
Yep.
So, big box of electronics, all the random bits of kit we've been accumulating. So what we're going to put on the end is some ferrules. You don't need to use these at all. We just like to use them because it's like how it tidies up the wires a bit. So we just need to put this in there, put the wires in, squeeze the trigger, and we'll get a nice compressed square that we can then slot straight into the terminal there. First thing we have to do though is we have to cut these down to the right size. So this cable is the positive, which is going all the way to the van starter battery under the seat, and this one needs to bend around into there. So do you reckon that'll be about there?
Yep.
Okay. Then we just snip that one, and that will bend into that bit. Possibly needs to be a bit more actually. Yeah, that's better, isn't it?
Yeah.
Cool. Really tough. Cool, so we've got those wires ready to go now, so they're just going to nicely tuck around there and then they just screw it in. And you might have noticed that we've got positive and negative here for both the van batteries and for our batteries, and that's because we've got the isolated version of the Orion, And if we look at the wiring diagram for that, basically the way this is set up is there is a positive and negative that comes from the Orion and then just goes to the van starter battery, and then also a positive and negative that comes from this side and goes to our house battery. And they also make another version which is called non-isolated, and that's this one here. And as you can see, it's pretty much the same setup. The only real difference is instead of there being two negatives, there is just one, and that's because the batteries in this one, they share a common ground. So effectively the negative is kind of shared between them. So in this one, you only have to wire 3 wires. So what we've got is the isolated, but we have actually also grounded our battery system, all our electronics, to the van chassis. So what we're going to be doing is actually using the isolated one in a kind of non-isolated way, which is fine. We'll basically just kind of lose the isolated feature because our battery and the van battery are actually sharing the same ground. At the time we were buying this, the isolated one wasn't actually that much more expensive, so we thought might as well get it so that we can, if we ever wanted to use it in a situation where we need something isolated in the future, not sure what that would be, but for example, if you had like a fiberglass boat or something where you didn't have a common ground because there's no metal chassis, then you would need the isolated one. We quite like the idea of having positive and negative wires going to each device in the van as well, just because we find it easier to reason about what current should be in each wire, and hopefully helps to break any ground loops we might have. We're going to wire it in the same way as if it was isolated, and it should be pretty simple because literally just 2 wires going from there to each battery and that's it. So quite a nice setup actually.
Okay, so all we need to do now is just to make the wires that are going to go from the Orion here to the links over here.
It's quite hard work, isn't it? Okay, should do it. These ones we need to use this heavy duty crimping tool, which it says you can do it with a hammer, but we've never found that to work, so advice it is. Yeah, nice solid connection on that.
Okay, so that's them done, and on the other ends we've just put some M8 ring terminals to fit onto the negative and the positive of the links there, and we've just put some heat shrink on as well, just to stop any moisture from getting in and to make it a little bit stronger as well. So
Cool, now we just got to do the ones at the front, and then basically we can just plug it all in.
groovy. So this is the other end of the wire coming through the bulkhead, and we made a little hole for some conduit to come through a little while ago, so that's already there, and we just need to cut it back so it's got the right length now.
The trickiest bit about this is it's a very awkward space to work in. Obviously can't use a vise, so this clamp just fits this thing, so we're going to try and use that. It's ridiculous.
Good.
Yeah, not too bad.
Nice.
So for attaching the positive side to the battery, the Transit actually has a little thing on the side here called the CCP, which is the customer connection point, and it's basically made for this kind of thing to attach some kind of accessory for. And there are 3 studs here. On some Transits all 3 of them are there. On ours we've just got the one in the middle. You can't really see it, but there's a bolt there that if we connect to that, that's actually a 60 amp fuse connection. So inside the seat base there's a little MIDI fuse, so we're just going to pop it on there. But what we thought as well is, because basically the fuse for this is like in the seat, if it ever did blow, from what we've seen, the only way you can change it is basically to take the seat out, which would be really annoying. So even though it's unlikely, what we thought we would do is put another fuse in line just before the CCP bit there, and then by doing that, if we use a slightly lower rated fuse, the idea is that ours would blow first if there's ever a problem, and then we can not have to faff around with the seat. Then for the negative one, which we're going to take to the battery negative, what we actually found is there is a tiny little hole in the back of the seat base, which was just big enough to get through the cable. So we've just put a rubber grommet inside there just to stop it from chafing on the sides, and then that allows us to just pass this quite neatly into the seat there, which we can then connect up to the battery. Keep going.
Is that alright?
Yeah, that's good. So today we've moved the van back a few metres because it was absolutely freezing. Just being in the sun makes a big difference.
Much nicer.
Yeah, we seem to always be doing stuff like this when it's like freezing. Literally it's like 1 degree. But anyway, we've got the cables made up now, all of them. There we go. And then have the really fiddly fun time of trying to screw that on there with really not much clearance. It's ridiculous. There we go. So Abby has got smaller hands, so she's now doing this with some mole grips attached to the little socket, which seems to be working pretty well.
Yeah.
So for connecting up the negative, there are some approved Ford grounding points, which you can find. Every Transit model has like a, what's it called, a body and equipment manual, which shows you where all the ground points are. And the nearest one here is kind of on the floor in the middle of these two seats, but it's actually under the floor and really awkward to access. So what we're going to do is actually just connect it directly to the negative of the battery, which is what Victron says to do in their manual as well. But yeah, as always with this kind of stuff, just make sure you do your own research, because we're not electricians, so we're just doing everything based on what we found on the internet and all the other resources. So yeah, we're just going to connect that up to that one. So that comes out, and then you can see the positive there and the negative there, and there is this quite convenient little cutout there with a bit of foam. So we're just going to run our negative through that one, and it should nicely find its way to the negative there. There you go. Okay, so it's the 10mm socket which fits on there. I might need something a bit stronger to undo it. Yeah, I need the torque wrench for that, I think. And now we can just add ours just on top of that one. There we go. Cool. Should give a nice secure connection on that. So now we need to connect the input side of the cables to the Orion, because the sequence, basically what you need to do is connect up the input side first, so the starter battery, and then you've got to configure all the settings and stuff, and also got to take out this little green plug which acts as the kind of jumper to activate everything. And just before we put the wires in, just with all the wires we do, we like to clean them with some isopropyl alcohol just to get rid of any grease and stuff. Just loosen the screw, and hopefully we've allowed a decent amount of bend for that to go in like that. Yeah, it's worked out pretty good.
Right, fiddly bit. Because this pillar thing is in the way. Just put back our little boxes that we made. Should still fit in.
Hopefully.
There we go.
You can see the lights come on, so we've now got power to the Orion. And because we've got the smart one, that basically means it's got Bluetooth, which is what the flashing light is. So now, oh yeah, there we go, it's already there. So I've got up the Victron app, and you can see the Orion's on there. Cool.
Nice.
So we're into it. This is the part where, because we've had our kit for a little while, we have to do a few updates. So we'll do all those and we'll come back to it. Might take a little while. Okay, so we've updated the firmware and now we are into the app. So not really showing anything at the moment, it's just showing basically the voltage at the starter battery. So that's the input side, and obviously the output is not connected yet because we haven't done that yet. So function, it has power supply and charger mode. We want charger, and then we need to change our battery settings. So it's using some default settings for lithium batteries, which is what we're using, but we do have some specs from our battery manufacturer, so we're just going to change those. The user defined one, so yeah, there we go, we can change those. So we just put in the values that we want for that. So one of the other things that's nice is that it has engine shutdown detection. So for some of the other DC chargers, you need to wire an extra cable to something that is live when the engine is running, basically, so that the charger knows when the engine's actually running. Because otherwise, if the alternator's not running and not putting charge back into the van batteries, and you start drawing it, then obviously you could end up draining your batteries. So that's pretty cool, and this one can do that without an extra wire. And if I go into that, you can also see that it works with smart alternators as well, which is pretty nice, and that's what we've got in our van. So for Euro 5 and 6 standards, to save fuel and emissions, the voltage from the alternator is not completely fixed. It's varying depending on what you're doing when you're driving. If we didn't have a smart alternator, you can use something like a voltage sensing relay, which is basically just a switch which opens at a voltage. But obviously that wouldn't work with a smart alternator because the voltage is dropping up and down around that level all the time. You'd hardly be charging at all when you're driving down. And also because we've got lithium batteries, we also can't use a just a simple relay like that, because the internal resistance of these is so low that basically means they'll try and draw a huge amount of current, which would be just too much. So you don't want to connect them directly like that, and why we've got something like this, which basically goes in between and just makes sure that everything plays nice to each other, and it understands both battery chemistries and types and all the settings, all that kind of stuff. So we're just going to leave these settings on the defaults, which should work pretty well for us. And one thing that's quite nice as well is it can do a delayed start, which is basically how long the charger will wait after the engine started before actually taking any power, and that's so it has enough time for the alternator to put back in the charge to the starter battery that it used to actually start the engine. So what we saw before, it was like 220 amps for a few seconds or so. So in theory, in that 2 minutes, it should be able to actually completely recharge what it lost before it then takes power to charge our batteries, which is quite nice. So now that the settings are all configured in that, we just need to actually connect up the other side. So obviously before we do that, just going to turn off all the power. So turn off the solar, just turn off the master switch. That just pops out. Then we just got to put the negative on that one and the positive on this one with the fuse going across that. So for the fuse, even though we've already got a fuse, actually 2 fuses now on the van side, you want to have one on this side as well, because you want one near each battery source basically. So you can see that in the Victron diagram, there's a fuse both on the van side, van battery side, and also on the leisure battery side. So conveniently we've got the link, so we can just easily add it in there. And we've decided to go for a 40 amp fuse in the end, which is a little bit lower than the one at the front, and that's because from what we've seen of the specs, it should never really pull 40 amps, and if it does, it'll only be for a few seconds. So actually we thought 40 amp fuse should actually be fine, shouldn't blow. Under normal use, so we're going to use that, and that just goes on there. I think that's basically everything wired up now.
Right.
We're pretty much ready to test. The only thing we have to check, which is a bit ridiculous, is that our batteries are actually warm enough to charge.
Let's see. One of them's 2 degrees, so I think 3 degrees is where it's all right. So might just need to warm it up a little bit.
Okay. They have a low temperature shut-off, which is pretty good because we don't have to worry about charging them when it's too cold. But it does mean if it is below freezing, they won't charge. So what we might have to do at some point is make a little heated jacket for them. We don't actually know if it's going to be an issue or not when we're on the road, because obviously when we're in the van and got the heater on, it probably will not be, hopefully will not be below 0 degrees inside. So
yeah, better not be. Right, I think they're just about warm enough for us to do it.
So one of us needs to go around to the cab and turn the engine on, and
Okay.
one of us needs to wait here.
What about this little gizmo?
Oh yeah, that's quite important.
So the last thing we need to do is to just put this remote bridge in, and you can actually wire in your own switch into this as well if you wanted to be able to turn it off manually, but we're not going to do that, so we're just going to pop that in there now. There we go.
So now we just need to turn on the van and hopefully it'll actually start charging.
Okay, so I'll go and do that. Hello.
Yep. Okay, we're at 15. Oh, there we go, and it's charging.
What's going on?
It has just started charging.
Woohoo!
Battery is charging with maximum current. Awesome. So, we should just be able to clamp around this cable now and see, there we go. So it's actually getting 35 amps, which is pretty nice.
Nice.
So we've had it running for a little while now, and as you can see it's drawing now exactly 30.0 amps. And if we look at the input side, so what's coming from the alternator side, you can see that's 34 exactly. So if we do the maths, that's 30 divided by 34 is 88% efficiency, which is pretty good because the manual says it's 87% efficient. So yeah, it's always a little bit higher on the input side than the output. And we can see how much it's going to be on the alternator out the engine as well. I love this tool, it's great. So now that we've got the DC charger hooked up and the solar charge controller, we can see how long it would take theoretically to charge a battery. So because we've got two 100 amp hour batteries and they're wired in parallel, that gives us 200 amp hours of total capacity. So then at 30 amps, which is if we had the DC charger running in full and nothing else, then it would take 6 hours 40 to fully charge our batteries from zero. If we had just the solar on at 50 amps, it would take 4 hours. And theoretically, if we could have full DC-DC and full solar, which is obviously quite unlikely probably in this kind of weather and climate we're in, but if we had that, it would take only 2.5 hours to fully charge the entire battery bank from zero, which is pretty cool. And obviously we're not going to be at zero, hopefully, otherwise we've done our calculations wrong. So yeah, and our batteries have a recommended 50 amps charge current, but that goes up to 100 maximum. But because we've got two in parallel, that actually gives us 100 recommended and 200 maximum. So we should be well within the limits of charging, and that's if we had literally everything charging as well, which is pretty good.
It's very cool. I think we're going to leave it there for this project. I'm not really sure what we're going to move on to next, but might do something about connecting the water up.
Yeah, that'd be nice.
See you then.
See you then. Bye.
Bye.